All right, look at this other roller coaster. This roller coaster, I'm going to tell you right now, is not 100% efficient. I've got friction, I've got drag. And just a reminder, because you might have forgotten, percent efficiency is equal to the total energy final divided by the total energy initial times 100%. I know when I was a kid in tech class, I can't even remember which tech class, but I remember the teacher's face. They talked about energy output divided by energy input times 100%. Doesn't really matter which version of that equation you like. I'm going to put a box around this one. This is the one that my physics teacher told me. This is the equation that my tech teacher told me. And it's the same idea, right? Efficiency is efficiency. Whether you're talking about, I don't know, auto class, or you're talking about a roller coaster. Same, okay? So the roller coaster has an 80% efficiency between points A and D. And you know, that's an important point. We can talk about the efficiency of this thing, but the efficiency may change between A and B versus A and D versus A and E. So we're just going to say that between A and D, there's 80% efficiency, which if you like, means that 20% of the energy is going to be lost. Okay? Either way, we want to think about that. Two sides of the same coin. On the previous page, so I'll just make a little comment here. See previous page. We did a question about a roller coaster in the previous topic number, and what we said was E total A is equal to EGA plus EKA. And I've kept the same values as we used on the previous roller coaster, except that this one's not, this is like one step more realistic by making it slightly inefficient. But we're going to say E total A is 98,162.5 joules. You have to look at the previous video to know where we got that from, but it's EG plus EK. We calculated it all out using the information over here and the height that we're at, 20 meters. E total at position D, though, if this is not a 100% efficient system, I can't claim that it's just the same as E total A anymore. My other given is percent efficiency is 80%. And remember, the formula is percent efficiency, and I'll put brackets around it because I honestly don't really like having like multi-letter variables like this. I think it's like a little bit ugly. I don't want to say trashy, but I don't like it, you know? I like one letter with subscripts. But anyway, I'll put brackets around it just because it makes me feel like a little bit more clean inside. E total divided by E total. Now, with my formula, I said final over initial. In this case, D is the stand-in for final, because that's our final point in the story, this little segment of the story we're telling. E total A is the first point in the segment of the story that we're telling, times 100%. And we can isolate to get E total D all by itself. Take that 100 over to the other side. I'm just showing all my steps. Multiply both sides by ETA. Equals ETD. Now, honestly, the only reason I'm showing all these steps, because I don't usually show that many steps, is that I want to make it really clear that at least when I calculate this, when I do this work in my head, I write it as percent efficiency is 80% over 100% times ETA. What's happening in my brain is I automatically just turn that 80% into 0.8 times the ETA. In other words, if I know that there's an 80% efficiency between point A and point D, honestly, in my head, I jump straight to this stage. 0.8 times the original. Does that make sense? To me, that's 4 lines of empty dealings, because it's just 0.8 times the original. That's what 80% efficiency means. But the formula really is like, you know, it guides the logic, right? Anyway, 0.80 times the original, 98,162.5 joules. I can't do that in my head. Somebody help me out. I think it starts with a 7, but I never trust myself these days. All right. 78,530. Is it exactly 530?
Yeah.
Are you lying right now?
No.
Oh my gosh. Wow. All right. And then oh shoot, 80% is only 3 sig figs. So we got to just roll with that. 7.85 times 10 to the power of 4 joules. Okay. And then it says to find the speed at position D. Now you notice that you had to have calculated the new total energy because of efficiency before you jump to the speed. And now I can jump to the speed and I can say, okay, well, E total D equals EGD plus EKD. And I didn't scaffold this as much as a previous question. I'm going to say ETD equals EGD plus EKD. Okay, I'll get the EKD all by itself. EKD, craft dinner, is equal to E total D, Toronto Dominion Bank, minus EGD, gosh darn, is equal to, sorry, no profanity. E total D was equal to 78,530 joules. I'm so glad that I had my coffee this morning. EGD, did we even calculate that yet? Man. Remember, that's mass times acceleration of gravity times height d. So the mass was 500 kilograms. 9.81 meters per second squared times HD in high definition is 13.0 meters. And then we can probably pop all this out. Yes, sir. Is it 15 meters? Oh my gosh. My coffee-addled brain read the wrong number. All right, thank you very much for catching that. 15 meters, thank you. All right, the Jeopardy music's playing and Avery's got the answer. What'd you get, Avery? 4.45 meters per second? Oh, you jumped all the way to the speed. I just want the kinetic energy first. The kinetic energy also starts with a 4. Yeah. 955, yeah. Jules, thanks, Wes. All right, so Avery jumped to the speed already, and you got it right. But let's like lay out our groundwork here, because EKD is equal to 1/2 mv2 squared, or mvd squared. VD all by itself. Equals, Avery, you said 4.45?
4.45197.
Nice. Meters per second. And of course, that's going to be approximately 4.45 meters per second. And again, if we were like so committed to the generalized equation, should I really do a generalized equation for this one? Can you see this going to be like a real bear of a thing, right? Because we would have to have E total D, EKD, okay, EKD would be buried right there in that term. And then we'd expand out where the heck we got this from. It actually becomes a bit of a monster because we'd also have to have the 80% portion built into it as well. Like it really expands right out. And so maybe that's a challenge that I'll leave with you, that I think that we could make a truly general equation for this based on original values and the 80% efficiency. But try it out. See if you can do it. See if you can make like the mega equation for this one that does all the steps all in one machine. And I'd love to see your answer on that one. But we'll call that one quits for now.